What's up, everyone? Welcome to the video. This is a review video on stoichiometry. Now, in stoichiometry, it is very math heavy. So if you want to be successful in this topic, you need to be able to understand some of these math concepts and where we're getting these numbers from. The most important thing when you're calculating stoichiometry problems is this. We like to call this the mole map right here. So a lot of the times we're going to be given a certain amount of a substance in grams. We'll call that substance A. And we're going to want to figure out ultimately how many grams of substance B that's going to put out. Now, sometimes we'll be going from grams of A to moles of A. Sometimes we'll be going from grams of A to moles of B. And sometimes we'll even be going from moles of A to moles of B, which, as we can see, are just a few steps. Now, an important topic that we need to remember from previous units is the molar mass. When we're going from grams to moles, we need to know what the molar mass of a substance is in order to determine how many moles of that substance that is. So molar mass, all that really is, let's say we have H2O. The molar mass is always, the units are in grams per mole. And what that means is however many grams 1 mole of a substance is. So 1 mole of water is 2 hydrogen atoms plus 1 oxygen atom. If we look at the periodic table, if I have 2 hydrogens plus 1 oxygen, the molar mass comes out to 18.02 grams per mole. Now, this is review, but it's important for us to know, especially when we are calculating for some things for stoichiometry. So when I'm going from grams to moles, I need to use the molar mass. When I'm going from moles to moles, I need to use the coefficients from the chemical equation. It's always important to balance your chemical equation before you go ahead and start solving stoichiometry problems. Sometimes the question will be balanced for you. Sometimes you will be required to balance it. So just pay close attention to the equation. Always make sure that it is balanced before you go ahead and start plugging any numbers into your calculator for dimensional analysis. All right, and then back over here, we're going from moles of B to grams of B, and then we would use the molar mass here again. So as you can see, we're starting with one substance, and we are trying to see how many moles or grams that can be of another substance. So keep this mole map right here in mind as we're going ahead and calculating some of these examples. So let's look at one right now. The first one says, consider the equation beryllium plus 2H2O produces beryllium hydroxide and hydrogen gas. So if I look here, this is already balanced for me. I have 4 hydrogens, and I have 4 hydrogens, 2 oxygens, and 1 beryllium. So this is a case where we don't need to balance, so we're pretty good. Let's also remember that there's a 1 coefficient here and a 1 here, as well as a 1 here, and then we already have a 2 coefficient for that. This is just a mole ratio. So essentially what this means is that for every 2 water molecules that I have 1 beryllium hydroxide, or for every 2 that water molecules I have 1 hydrogen gas diatomic element or molecule on the other side. So keeping these ratios in mind is going to be important. How many moles of beryllium hydroxide are produced if 6.5 moles of water reacts with excess beryllium? So when I'm looking at a question like this, I'm reading the question and I'm seeing what's given to me. What's given to me is 6.5 moles of water. And what I want to find is the number of moles of beryllium hydroxide. So this is what I want, and this is what is given to me. You always need to start with your given. And as you can see, the units, we're going from moles to moles. So we're just going to be going from moles of A to moles of B, which is an easy one. That's all it is one step using our coefficients up here. All right, so let's start with what we're given. 6.5 moles of H2O. And we want to figure out how many moles of water that's going to produce. When we're doing our dimensional analysis, we always put the units of what we are looking for, what we're trying to solve, on top. So moles of beryllium hydroxide will go on top. And then moles of water is going to go on the bottom. All right. Now let's refer to the chemical equation to see how many moles of each of these I have. If I look at the equation, there's 1 mole of beryllium hydroxide for every 2 water molecules. So there, and I just drew these numbers straight from the chemical equation up top. 1 mole of beryllium hydroxide, 2 moles of H2O. So then all you have to do is, well, first we would cross out the units, leaving moles of beryllium hydroxide as the unit that I'm solving for. So all you have to do, multiply the top, divide by the bottom. So it's 6.5 times 1, which is 6.5, divided by 2, which comes out to 3.25 moles of beryllium hydroxide. And that would be your answer. So you see, this was a pretty easy one. All it took was one step here, just going from moles of A to moles of B. All right, given what I want to find, and then we have to make sure that everything is balanced on top. All right, so there's a simple one. Good one to start with. All right, next question. How many grams of lithium nitrate are produced if 1.5 moles of barium nitrate and excess lithium react? All right, so what I'm given is 1.5 moles of barium nitrate. What I'm trying to find is grams of lithium nitrate that are produced. So we need to write out the equation for this. We have barium nitrate and lithium reacting, so that's going to be BaNO3 plus Li. So single replacement reaction. Lithium will switch places with barium. So what that gives me then, what that produces is lithium nitrate, LiNO3 plus barium. All right, now let's see. We do need to balance this. I have 2 nitrates on this side, so I'm going to need 2 on this side. So that gives me 2 nitrates, but that also gives me 2 lithium. So I'll have to put a 2 in front of the lithium in order to go ahead and balance that out. All right, so first step is complete. We balanced our equation. We have to realize that our equation is not balanced, and then once we do that, we're good to go. So we can put a 1 here and a 1 here, just so we can keep track of how many moles we have. All right, secondly, what we're going to do is we're going from moles of one substance to grams of another substance. So we're going to first need to figure out how many moles of lithium nitrate that 1.5 moles of barium nitrate yields. And then from there, we'll see how many grams of lithium nitrate we actually get out from the number of moles that we have. All right, so let's just go ahead and write this out. What I'm given is 1.5 moles of barium nitrate, BaNO3, 2, and we're going to draw out my dimensional analysis. I already know that I'm going to be going 1, 2, 3 steps here, and I want to end in grams of LiNO3. All right, so wrote down what I'm given. Anytime that I want to cancel out my units, I need to put the same units on the bottom. So I need to put moles of barium nitrate on the bottom. Whenever I'm going from moles to moles, I use the mole ratio. So I need to have lithium nitrate on top, and that would be moles. And then I look at my balanced equation to see how what the mole ratio is. If I want to go from moles to moles, I need to use a mole ratio. So I have 2 moles of lithium nitrate, and I have 1 mole of barium nitrate. Notice how I have a 2 in front of here and a 1 in front of here. So that's where I got my numbers. All right, so that step's good. We can actually cancel out moles of barium nitrate. And now we need to see how many grams 2 moles of lithium nitrate gives me. So 1 mole of lithium nitrate has a mass of 68.95. Now all I did was I took 1 lithium and 1 nitrate and added those up from the periodic table, and that's where I got 68.95. That cancels out my moles of lithium nitrate. So now I'm left with grams of lithium nitrate on top, and once I go ahead and multiply the top and divide by the bottom, I get the value of 206.85 grams of lithium nitrate. So all I'm doing is I'm seeing what I need and what I have, and I'm just going ahead and using my mole map to calculate this out. Start with moles, end with grams, and you're good. One more example. Now this one, we can go two different routes with this, and it's really up to you. And let's read it through and see what it's asking. If 79.80 grams of aluminum nitrate reacts with 67.1 grams of sodium hydroxide, what is the theoretical yield of aluminum hydroxide? Anytime it's asking for the theoretical yield, all it's seeing is how much we can get out from the product, from the reactants that we start with. So don't let this confuse you. We don't need to determine any type of percents or anything like that. Theoretical yield, all that's asking is how many grams can we get out from what we're starting with. Now, we're given two values here. If we look, we have sodium hydroxide, which is one of my reactants, and I also have aluminum nitrate, which is another reactant. What it's looking for is the mass of aluminum hydroxide. Either one of these are going to yield aluminum hydroxide. So I don't need to use both of these numbers when I'm calculating theoretical yield. I can actually just choose which number that I want to use. So if you prefer to use aluminum nitrate, you can. If you prefer to use sodium hydroxide, you can as well. I'm going to use sodium hydroxide. I'm just going to use this number and go ahead and go from grams of one substance, so grams of this, to grams of aluminum hydroxide. So that's going to actually come out to be 4 total steps. And we'll go ahead and start this off. So always start off with what you're given, which is 67.1 grams of NaOH, and we're going to draw out my dimensional analysis 2 and 3. So this is the most that we're going to ever have to do for a stoichiometry problem. We'll need to be able to go all the way from grams of A to grams of B, and what we want to end up with is grams of AlOH3. I'm going to run out of room here. All right, we're good, whatever. So let's go from grams of sodium hydroxide to moles of sodium hydroxide. We need to use the molar mass in order to figure this out. So 1 mole NaOH. We look at the periodic table. 1 sodium plus an oxygen plus a hydrogen comes out to 40. Oh, just caught a mistake here. So remember how I always said that we want to cancel out units. We want to make sure that we are putting grams on the bottom. That way grams of sodium hydroxide can cancel out. So I was getting a little ahead of myself there, but I'm happy I caught it. Now we can see why we need to put the grams on the bottom. That way we can cancel out the units. So 40 grams of NaOH is going to be on the bottom this time. And then we're going to have 1 mole of NaOH on the top. Okay, so now grams of NaOH can cancel. Now we need to go from moles of NaOH to moles of aluminum hydroxide, AlOH3. And I need to put moles of sodium hydroxide on the bottom. All right, so this is where we use the mole ratio. This is a balanced equation, if you notice. So we don't need to do any balancing. We just need to look at what coefficients are in front of each of these substances in the chemical reaction. So if I look at the equation, for every 1 mole of aluminum hydroxide I have, there's an imaginary 1 here, there are 3 moles of sodium hydroxide. So it's a 1-to-3 ratio. So that's going to help me out here. All right, so I use my mole ratio in order to help to change, in order to go from moles of A to moles of B, moles of sodium hydroxide to moles of aluminum hydroxide. All right, now last step, 1 mole, we need to go from moles of aluminum hydroxide to grams of aluminum hydroxide. So we're going to use the molar mass yet again. 1 mole of AlOH3 has a mass of 54.01. That's just 1 aluminum plus 3 oxygens plus 3 hydrogens. All right. So once you go ahead and calculate that out, we cancel out moles of, we can cancel out all of our units to end up with grams of aluminum hydroxide. Multiply by the top, divide by the bottom, and what I come out to with these values is 30.20 grams of AlOH3. Okay, so there are 3 examples of stoichiometry problems that you will see. We went from moles to moles, we went from moles to grams, and then lastly we went the furthest that we'll ever have to go in stoichiometry, which is grams to grams. It's a 4-stepper. As long as you know molar masses, as long as your equations are balanced, you should be good. Now let me know if this video helped you. If you need more examples, please give me a shout out. I will help you out as much as you need me to. Until next time, we'll catch you later.